plastic is contaminating our deepest oceans. It's contaminating our highest mountains. We're finding it in Arctic sea ice. So it's all pervasive because of the colossal quantities that we've produced and failed to manage.
Coming up on British Thought Leaders, Professor Richard Thompson on tackling the millions of tonnes of plastic that enter our oceans every year.
The ocean didn't make any of this plastic. It's all come from the land. It's come from the things we do on the land. That's where the drivers are.
Professor Thompson says products need to be designed with end of life in mind.
What I'm seeing is arrival into the marketplace of things that have not been properly tried and tested, that are claiming to be part of the solution,
Right.
but we don't necessarily have the evidence that they are. And in some cases, there's evidence that they could make matters worse.
And that change needs to come from corporations and governments, such as Britain's world-leading microbeads ban.
You have to ask the question, did nobody in the industry ever wonder where all of these literally hundreds and hundreds of thousands of tons of small bits of plastic that were being put into cosmetics every year, where were they going?
Welcome to British Thought Leaders. I'm Lee Hall. Today I'm sitting down with Professor Richard Thompson, a marine biologist who first identified microplastics. Richard, welcome to the show.
Well, thank you for having me.
You've dedicated your career to the ocean. For a lot of us, it's quite far away. I mean, can you set the scene by telling us why the ocean's important, what role it plays in our lives?
Well, actually, I mean, for some of us it's quite far away, but the majority of the world's population actually live within, a few tens of kilometres from the ocean, and so we're actually really incredibly connected. But to some extent we've disconnected ourselves, not by geography, but by the way we run our lives these days. I talk to youngsters sometimes, and I ask them where the fish come from, and they say, well, it comes from the local supermarket, even if they're living by the coast. So I think we've disconnected ourselves, but actually geographically and in terms of the things that we need to support us, most of the population are very close to the sea. I mean, even the waters here at London Bridge are tidal, right? So incredibly important. Most of the human activities are going on in that region close to shorelines because they're more accessible, whether that's for fisheries or other resources. Of course, we're now starting to exploit areas much further out in the deeper oceans. But the oceans have been a source of food and materials and resources to humans for as long as we've been here, really. We're reliant on them. But also, they have a critical role in actually maintaining the balance of the planet as a whole, helping to regulate climate, helping to regulate, the air that we breathe. So incredibly important to the survival of all of us, and yet, for a while, at least, we've tended to treat them as a place to discard waste because you can't see beneath the surface of the water. So I think in terms of this separation that you kind of alluded to between humans and the oceans, it's getting a better understanding of what lies beneath and the role of oceans that I think is particularly important in making that connection. And I do think it's a connection that we've lost. I remember speaking to a First Nation North American at a UN conference, actually, and he spoke the most sense, in my mind, about the connectivity between land and sea and the reliance on protecting the environment for the things that we humans rely on. And I think a frustration for me at times is that we tend to compartmentalise things. So even if I'm working with government agencies, quite often they will be separated between the land and the sea. And it's the same, frustratingly sometimes, with funding calls. I remember a funding call related to plastic, an EU call, and it was very much dedicated to plastic in the ocean. And I was saying, but the ocean didn't make any of this plastic. It's all come from the land. It's come from the things we do on the land. That's where the drivers are. So we need to connect the land and the sea to solve these problems. And I guess when I'm going around in circles a bit, that's something I feel we've lost over time, is the importance of nature to all of us, and particularly the importance of the oceans and the aquatic environment.
So these plastics that are going into the ocean, how much of it is there? Where do they come from? Where do they go?
Incredibly diverse sources, and I mean the total quantities, there are many different estimates. I mean, some would suggest it's as much as 10% of all production that's ending up in the sea, but these are slightly back of envelope calculations. Could estimate the trillions of particles of microplastics, or you could turn it into waste. I think the key point is that it's impossible now to walk on any shoreline without finding plastic debris within a few meters. We know that plastic is contaminating our deepest oceans. It's contaminating our highest mountains. We're finding it in Arctic sea ice. So it's all pervasive because of the colossal quantities that we've produced and failed to manage appropriately.
So microplastics, so you first identified them. You were named the godfather of microplastics here in Westminster. What are they, and how did you first identify them?
So what first got me interested in the topic was I was training to be a marine ecologist at the time. I mean, I'd done some work on plastics. I was interested in the topic because I was aware, and this is back in the 1990s, I was aware that it was becoming increasingly important as a contaminant. But I was working on shorelines. I had experiments set up, and I needed to go to look at those experiments every day and count the shellfish that were there and the algae that were there. And what I found is every day I'd got plastic and other litter arriving. It's mostly plastic, but arriving in those experiments, and I had to clear it each day. But the next day there'd be more, and it sort of got me curious. And so, nowadays we quite often hear about beach cleaning events, but at the time, back in the 90s, it wasn't so common. Marine Conservation Society in the UK was starting to organise national cleans, and so I mobilised some of the students alongside me to do some beach cleans, and that's exactly what we did. And looking back, it feels like an everyday thing now, but at the time, having a database, having Excel that you could put things into as a scientist was quite a new thing available to a PhD student. So I was transferring all this stuff from paper sheets into these into spreadsheets, and it just struck me as I was doing that what I considered was the most abundant type of plastic on the shore was actually not being recorded. It wasn't being documented. It wasn't being removed, and that was the very small pieces. And it got me curious because they seemed to be incredibly abundant. But almost there was a temptation, I think, to want to remove the biggest item, almost like a trophy item, a big tyre, a big fishing net. And lots of energy went into removing those, which of course we want to remove, but we were missing something. And that coupled with the fact that if you looked at the time, that there weren't many sort of long-term data sets of plastic litter in the environment. But the ones that we had, they didn't show this increasing trend that you'd expect that would match the production statistics. It sort of showed noise, variation from year to year. And it struck me, and that most of that data came from beach cleans. It struck me, maybe the reason that we don't see a pattern is because we're not counting some of the things, that the plastic is fragmenting into smaller pieces and then we're not counting them. But also perhaps it's ending up in other places like the deep sea that I alluded to. So when we wrote this paper, which was the first to use the term microplastics in that context. Others had found small bits of plastic before and they'd found them since. But in that paper, 2004, we went smaller than anybody else. We showed the widespread accumulation. And the critical thing in relation to the point I'm making about this long-term change is when we looked at the small pieces, we did, for the first time, see this year-on-year increase. We showed significant increases over the decades. And that's why I called that paper Lost at Sea, Where is All the Plastic? Because I was alluding to the fact that we were missing it in some of the observations. We also showed that a wide range of creatures could eat this material. Now that in itself doesn't prove the microplastics are harmful, but it indicated a bioavailability, a pathway that could potentially cause harm, and harm was something we went on to investigate.
How small are we talking for these?
Now that's a really interesting question, because in that first paper, to use the term microplastics, we went as small as you could go with the analysis at the time, which was down to around about 20 microns. I mean, less than the diameter of a human hair. Right. When we looked down the microscope, pieces smaller than the grains of sand that were the beach itself, if you like, to kind of put it into perspective. That's still, technology's improved a bit, but we still can't really get into the nanoscale below 1 micron and confirm, this is a piece of polystyrene or this is a piece of polyethylene. So we're kind of still right at that boundary of the threshold for pulling back from an environmental sample a single piece and going much smaller than we did back in 2004. Now, all of those pieces were microscopic, which is why we called them microplastics. Now, since then, policy circles have tried to put a more formal definition on, because we were just describing this accumulation, and really the heart of that paper was about the fact that we'd been missing it, right? Rather than trying to define it necessarily. So policymakers became interested in this topic, and there was the first policy meeting actually around about 2007, 2008 in the US. And one of the things that from the discussions at that meeting was the potential for these small bits to have impacts in different ways to the larger items that we'd already got really clear evidence were harmful. So it's easy to picture perhaps a marine mammal becoming entangled in netting, or a seabird, its digestive tract becoming blocked by larger pieces of plastic. And you've probably seen pictures of those with albatross, for example. But the potential with these smaller particles was for them to be available to a much wider range of creatures. A creature much smaller than a seabird, a creature that couldn't eat a bottle cap, for example. And indeed, what we've subsequently gone on to show is that the really small pieces have got a potential to go even further. They'll pass from the digestive tract into the circulatory system. So these small particles, I think that was the point that raised interest from policymakers. They've got potential to be much more available to a wider range of species and to cause harm in different ways. When we get to these smaller particles that can be taken from the digestive tract into the circulatory system, and we've demonstrated that, what we're also starting to see is accumulation in some body tissues, in some organs. If we look at invertebrates, the hepatopancreas, which is kind of analogous to the liver in humans, and we're seeing the particles go in but not necessarily come out. Now that will depend a bit on the physiology of the creature, but also the shape and size of the particles. But where I'm driving to is that I suspect as the science unfolds, we'll see that some types of microplastic are more harmful than others, and that will be driven by the size, but also the chemical nature of the particular polymer type. May present different challenges, and also potentially the shape of the particle.
So we think they're building up inside the creatures and not coming out.
Well, there's evidence. I mean, most of the laboratory studies, it's harder to conduct a really long-term laboratory study. Most of ours have run over about 4 weeks or so, and after that, if we expose a creature to a single pulse exposure, if you like, a one-off exposure, and then we keep moving it to clean conditions, so it's not re-ingesting its feces, it's not gone back into the water and gone around, so it's moved to clean conditions. Even after 4 weeks, we can still detect the presence of those microplastics in tissue. So some of it goes in and comes out quite quickly, but it seems that some of it has the potential to stick. And of course, we're becoming increasingly interested in the potential implications for human health. Now, that's not my area of expertise as a marine biologist, but 2 weeks ago, I was at a major European conference of all of the liver consultants, not just in Europe, but much further afield, several thousand of them. And there was a dedicated session just to looking at the issue of microplastics in the liver. And so, there is concern there, I think, for human health. I'm anticipating a question here, but what I would say is there are unknowns about the extent of the impact on human health. But the key point I would say is that any unknowns that we've got, in my view, about plastic pollution and microplastic pollution are not sufficient to delay in taking actions. Or putting it another way, we know more than enough to know that we need to change our ways. There are unknowns, and some of those with a low ambition for change will say, well, the science isn't there yet, it's not complete, we've got to wait for the science. And I would argue we actually know more than enough that we need to make a change. And that's to some extent endorsed by the fact that currently we've got 180 nations that have agreed to work towards a treaty to end plastic pollution. And that, to me, is quite an important step. And it's different to 20 years or so ago when I really first got involved with policymakers, in that at that time, 20 years ago, there wasn't really a consensus that this was a problem. Now I think we've got a consensus. We've passed that tipping point for evidence on the problem. The slight frustration that I've got when I look at scientific papers that I review, or grant applications that I review, or presentations at conferences is that, 85% of them are focused still on defining the problem, and I think we know there's a problem. Only 15% are addressing the what do we do about it. And so the area where I think we really need to focus is the nuts and bolts, the granularity of specifically what do we need to do about it. I hear, policy makers at a UN meeting, very frequently they'll stand and they'll say, we know what to do. We must reduce, reuse, recycle. And of course, all of those things are still right. But that phrase, reduce, reuse, recycle, was born, I think, Earth Day 1970. The detail of the science of what do we need to reduce? What don't we need? What do we need to design for reuse? How do we get to increase the appalling levels of recycling? It's moving on at a rate that's slower than I would like to see. And there is a risk here, because I think that now we've got this alignment that there is a problem, and also the public are very alarmed about it. And they want to, that's the thing. The biggest question I get asked normally in an interview is, what can the public, the listener at home, do? And it's really challenging at the moment, because very few plastic products have been designed with end of life in mind, and it's hard for the consumer to play the role that they'd like to take. And frustratingly, what I see is some things coming into the marketplace, coming into that market opportunity, and there is a real market opportunity here. But what I'm seeing is arrival into the marketplace of things that have not been properly tried and tested, that are claiming to be part of the solution, but we don't necessarily have the evidence that they are. And in some cases, there's evidence that they could make matters worse. And that worries me a lot. So,
But does it need to be at the design phase they're thinking about the end of the product and where it will end up?
Well, that's a good point. We need to look at both. And that is it's a critical failure. And I only really became aware of it about in 2007, 2008. I was putting together a volume of scientific papers about the issue for the Royal Society, a volume called Plastics, the Environment and Human Health. And we wanted some of the science about the impacts, but I also wanted to understand, because, let's be clear, plastics bring many societal and environmental benefits. It's about how do we keep those without the present levels of harm. And so we had in this volume a paper from the producers of plastic, but also those that dealt with recycling as a potential more circular way. And it was really interesting when you looked at these two papers. I'm thinking, these teams, they don't talk to each other. It's really clear that and it reminded me in a biological sense of almost what I call a kind of biological arms race of a prey species developing a thicker and thicker shell to cope with a predator that was developing ever stronger crushing claws. So the recycler would be saying, "Oh, we've now come up with this fancy infrared technique that can spot this material that's challenging to spot and to identify." And I'm thinking, but why don't we design it in a way that would be compatible with the recycling team? I remember, really strong memory of going to a recycling plant not that far from where we're sitting here in London, a really advanced recycling plant just a little bit further down the Thames. And we went to look around it. We'd got hard hats and hard boots and PPE on. There's material flying around that's come from domestic waste at high speed. Really, really impressive facility, trying to separate, because that's the key to it. It's separating it so that you can turn it back into value, because you look at the waste we generate at home, and it's a really complex mixture, and that's part of the solution is actually simplifying that complex mixture. But to come back to the recycling plant, I've got all this material flying around. And then at the end of the line, there's a conveyor belt that is basically either going to go to incineration or to landfill. And there's all of these fancy detection gadgets doing all the rest of it. But at the end of the line, there's a human being stood there. And that role at the end of that conveyor belt, it's 7 days a week, 365 days a year. And the main purpose of that, from a point of view of actually the cost of that person, is to spot one type of fizzy drink bottle, a sports drink bottle, that underneath it, the bottle is a highly valuable polymer, one that we know we can recycle, called PET. But for reasons, I'll allude to the reasons in a minute, but for their own reasons, the industry, the manufacturer, has chosen to clad that bottle in a thin film wrapper of another polymer, right? In an orange wrapper. Now, they've done that not to protect the food or drink. And let's be clear, plastics can reduce food wastage, but this wasn't there to do that. It was there to achieve brand differentiation on the shelf. But in doing so, the designer had effectively camouflaged the high-value PET that had the potential to be circular from our best recycling technology. And I just think we don't have the resource on the planet to squander it in that kind of way. I mean, you've added something here by design. This is an additional cost. It's an additional material that's used, an additional non-renewable material, an additional cost to the consumer, an additional waste, just to achieve brand differentiation. And at the same time as that wastefulness of the wrapper itself, you're running the risk of actually taking one of our more recyclable polymers out of the circular system. So, it's a frustration to me. And when it's really interesting. When I speak to product designers and I say, well, what about end of life? They say, oh, crikey, that was never in the brief. So I don't specifically blame the product designers, but we do need to start to think about this. They say, well, what was in the brief was making it function and making it attractive to the consumer. But we can't carry on like that. So we've got to start thinking about it in a systemic way. From the product design, we need to think about, is it a reuse format? Is it about using less material, or is it about getting it more compatible with circularity? And in some places, those things conflict, but we just don't seem to be joined up in our thinking, unfortunately. And part of that, I think, is going to need to be driven by policy measures to either pull in the right direction or push away from the things that are not working.
Have you seen much reaction in the corporate world in the past 20 years or so to this issue?
Well, of course, yes, there is reaction, and that's great, and it's absolutely what we want. I described the frustrating example of the plastic bottle, and I'll give you another example that frustrated me. And so we need this corporate interaction. The other one that frustrated me was the microbeads in cosmetics. And we've seen the legislation in the UK, and it was actually one of my PhD students that produced it was the only scientific paper that was cited in DEFRA's evidence to Parliament on this, where we showed, or she, a really smart young student called Imogen Napper at the time, this is nearly a decade ago now, showed that some of these single cosmetic products could contain literally 3 million small plastic particles, something the consumer couldn't do anything about. They couldn't take them to be recycled. It was inevitable they were going to pass into wastewater. And we know that there are so many larger items that escape our wastewater system. The wastewater system certainly isn't designed to tackle bits less than a millimetre. And of course, that it's entered legislation that there shouldn't be these plastics in rinse-off cosmetics, and we've seen that now followed in other countries, and that's really pleasing to see. It's not everywhere, but really pleasing to see. However, when you look back and look at the dates when the patent for the use of small bits of plastic in cosmetic products like that was first filed, it was 50 years or so ago. And you have to ask the question, did nobody in the industry ever wonder where all of these literally hundreds and hundreds of thousands of tons of small bits of plastic that were being put into cosmetics every year, where were they going? I mean, so we need that cooperation. To some extent, it needs to be driven by industry asking those questions and asking science to help. And, just actually on the train this morning, I was discussing with a manufacturer of textiles and garments about how could we do some testing. Yeah, and so it's moving in the right direction. But there's a challenge, because how do we fund that? It's really difficult for one manufacturer or one company to bear the burden of all of that research and development. Right. But it worries me a bit that it's not maybe sufficiently exciting for some of the big national funding bodies that want to be something more of a moonshot, a discovery, and I sometimes hear they'll say, well, you're talking about refining a product to make it more recyclable. Surely that has to fall with industry. And I agree with them. It's just which industry? Who's going to pay for it? Which company should decide? And there is, to me, there is a real opportunity here in being, a first adopter, but it's difficult for one company to bear the brunt of that. Yeah. And then the other challenge for industry is when, and we've had this just recently with one company we were working with, the results of the experiment didn't come out quite the way they wanted them to be. They didn't necessarily result in evidence of less harm from their product, let's say, compared to another one. And of course, that wasn't the result that they were hoping for. And so then they didn't really want us to publish those results. But what I need to do is to provide independent evidence, and that's one of the challenges, that there is evidence coming from scientists employed in industry, but it tends to be cherry-picked. So we need evidence from independent scientists, but the frustration here is, I think, it's not so much that there's not an industry appetite for it, it's just how do we fund it, and I think it's wrong that we should expect that it should fall on the shoulders of individual companies. But if it does fall on individual companies, then you've got this potential conflict of interest that either they can't afford the cost, or they might be concerned that we might find something that they don't really want to hear, and it's a real worry. And we've been working with industries for a while now, and I often try to have that conversation up front and say, look, we might not, the results might not show your product in favour, but we need to know those results and we need to publish them. And are you happy to proceed on that basis and pay for the tests? And that's often a little bit of a watershed moment for them. And I appreciate why, which is kind of why I'm saying I think we need to think about a mechanism to fund the kind of testing to show us, to indicate better way forward in terms of more responsible use of plastics. But we need some statutory funding available to do that. I mean, maybe it could be, you know, if I think of other parallels with the oil and gas industry, there's a funding scheme called Insight where the companies put in about half of the funding and the government puts in the other half. Maybe we need something like that. But a lot of it isn't rocket science. It's fairly, well, it's critically important, but in terms of what you're actually doing, it may seem quite dull and incremental. But, you know, we do need to know before we switch from garment made of fibre A to garment made of fibre B, that fibre B is better, not just different. And that's my worry at the minute, that there's a danger we might move to things that are different without knowing whether they're better. And as I say, some of the things that we've tested and evaluated are either having no effect or they're potentially worse. We tested devices that were intended to intercept microfibers in washing machines. We tested 5 of them. 3 of them had no effect whatsoever, but they were on the market. People were buying them with good intent, but they had no effect. The other 2 did reduce the emissions from the back of your washing machine, but the reduction was quite small compared to the scale of the reduction that we'd already shown could be achieved by better design of the garments in the first place. Yeah. So we need to make sure that solutions are properly tried and tested.
Is there much appetite in Britain at the policy level for this type of thing?
Oh yeah, absolutely. Definitely there is. You know, I have a lot of interactions with DEFRA. I think there is a real keenness to move in the right direction. It's challenging though, because, and that's why I think the UN Treaty is so important. It's hard to do something at the level of an individual nation because plastics are traded internationally. And so, you know, to go back to that example of the filters for washing machines, and this, you know, the French have now mandated that is going to be an approach going forward, that all of the washing machines in France will have a filter fitted. And some politicians in the UK are advocating the same. And it creates a slight conflict for me because on the one hand, of course, as long as the filters are the ones that work, I think that would be a good thing to do. But at the same time, it's a frustration that I also know that you could achieve a much, much bigger effect, up to an 80% reduction potentially, by designing the clothing in a different way. Right. And when I ask the politicians, well, why don't you want to move for that rather than a filter? Because on a global scale, let's not forget that most of the human population don't have the benefit like we do of a washing machine at home. And on top of all of that, we've also shown, the science is telling us, that half of all of the emissions of these fibres, and I'm getting quite specific, it's only one, you know, of the microplastic sources, but half of all the emissions of them come while you're wearing and walking around in the clothes, not while you're washing them. Right. So the filter on the washing machine is never going to fix that, but the better by design of the garment, the textiles, the yarns, would fix it whether you've got a washing machine, not got a washing machine, the emissions to water and the emissions to air. Why don't they want to do that? Well, the response from the politician was because that would require, you know, international legislation, international changes. It would be very difficult to implement, whereas retrofitting a filter onto washing machines, not easy, but would be relatively simpler as a policy move. And I do see that, but to me the opportunity that we've got at the moment from a UN treaty is that we aspire to something above the actions of individual member states, and that we get proper standards in place that we can assess. I mean, in simple terms, I think what the treaty needs to include is scope, once the treaty is adopted, to look at the essentiality, first of all, of plastic products, to make sure that we're only using plastics in ways that are essential to society or the environment. And you could take some single-use carrier bags, or you could take the microbeads in cosmetics. They're clearly examples of things that in many situations we could manage without. Yeah. So we need to look at essentiality criteria. We then need to look for those products that are essential at the safety and sustainability criteria. So is the plastic designed in a way that makes it highly reusable or repairable in the product, or is it highly compatible with circularity? So we need to look at, you know, we need to look at the sustainability of it, but we also need to look at the safety of it. We now know that there's some 16,000 chemicals associated with plastics. Wow. About 4,000 of them are known to be potentially harmful. Very few of those are regulated, and many are not disclosed on the product. So it's very difficult to know what's in the product in the first place. And that makes it almost impossible, going back to the challenges to the recycler. I mean, because, you know, you could have 2 bottles that were fulfilling a similar function, but they can have quite different chemical composition. And so it's difficult to know the provenance of the material that you're trying to recycle. They get mixed together, and the quality of the bottle that you want to make out of that recyclate is compromised because you've now got this much more complex mixture than what was already quite complicated to start with. So to some extent, part of the solution is in simplifying. So the safety in terms of making sure we've not got potentially hazardous chemicals there, and that's why it's really important that this UN treaty includes the consideration of the chemicals that are in plastics. There are some that would say, well, we've got other conventions that deal with harmful chemicals, but there's nothing that addresses the multitude of chemicals in plastics, or nor do they necessarily address them for the same reason. So we need to be sure the chemical composition of the plastics is as safe as possible. There may be exemptions to that, and they need to be reviewed on a case-by-case basis. It could be medical applications or particular applications in farming or fisheries where there's no other way of doing it. But we need to start from the premise that we want to use plastics for essential uses. Then we want those plastics to be safer and more sustainable than they are, and that needs to include the chemicals. And the chemicals is a safety issue, but it's also a sustainability and circularity issue, because it's this complex mixture of chemicals that we're using, 16,000 or so of them, that is making it even harder to recycle something in a way that's safe and also is a product that you can rely on.
You're joining us today on the way to the United Nations Ocean Conference. Are positive things happening at this kind of wider international level?
Yes, they are. I mean, it's always going to be challenging to get, as we need with the Plastic Pollution Treaty, and that'll meet for what's hopefully its final round of discussions in Geneva this August. But there's a lot of moves at the UN Ocean Conference in Nice to try to get member states positioned aligned so that we can reach some sort of consensus at the later meeting focused on plastics in August. And we see a real groundswell of what some have called a coalition of the willing, of the countries that really want to step up towards an ambitious treaty to end plastic pollution. But of course there are those that don't take that position, and there are a variety of reasons for that. And of course, like any treaty like this, there are going to kind of be winners and losers, and that's what is stalling things a little bit. That some countries see that potentially their export markets, and the carbon source for all of this is fossil oil and gas, that might compromise their sales, their market opportunity, their exports. So you can understand that the views are divergent, and they're not all driven by the benefit of the environment, because of course as a representative of an individual country, you've also got to think about the economics of your country. Sure. And some of the developing nations are concerned about the cost to them, not necessarily the cost of the exports, but they're worried about the cost to them. So I spoke with one member state going back to one of the previous meetings, and he said, he was from a less well-off country, it doesn't matter where, but he said to me, I totally get what the science is telling me about the potential harm here. My heart is telling me I need to, join those that want a high aspiration, but my head is telling me that my country might not be able to afford that. And it was interesting when I tried to unpack with him, well, what aspect is it that you think could be particularly costly? And some of the things that came back, I actually wasn't convinced that there was going to be the cost that he perceived. Right. And you're at these negotiations with some countries that are so large or have got so much at stake here that they're bringing really big delegations, sometimes of a dozen people who all are experts in their field. And then you talk to a small island developing nation that can only afford to send one person, and quite possibly their background isn't in the environmental science that might be needed to understand the problem. So there is in the middle between those with a high ambition and those with a low ambition, there's the undecided for a variety of reasons. And it's a frustration to me that, I suppose maybe I came into the politics of international negotiations slightly naive, but I imagined that after so many years of the UN trying to negotiate such international treaties, that they'd have a little bit more of a process established. And the frustration to me is that there's been no independent science body stood up to guide countries, because I see that the right to accurate, independent scientific information is a fundamental human right. And at the minute we've got an imbalance in the treaty negotiations between some countries that can afford that knowledge base, that have got the trained scientists in policy, and some smaller nations that haven't. And the bigger nations that have are to some extent some of them at least, cherry picking their facts to suit their argument.
Right.
And of course, you know, and then you've got the ones that are undecided in the middle. And of course, ultimately it's a political decision, but it frustrates me as a scientist that's worked on this topic for nearly 30 years that there isn't a mechanism to deliver science that's free of conflict of interest to guide the process. And I, you know, naively came into it imagining that that would be something that the UN would establish early on to make sure that all of the negotiations had got the best evidence at hand to guide them in their discussions. But unfortunately, that's not the case. And so, together with a group of other scientists, literally a handful of us, going back nearly 3 years now, we established an independent group called the Scientists Coalition for an Effective Plastic Treaty. And it's grown from this small handful of individuals to now more than 400 members, independent scientists across 63 countries. And we're all trying to supply that evidence, but this is a voluntary organisation without any funding. Even getting our scientists to the meetings requires them to be, you know, to have the time away from their day job of teaching and research, to have the funding for the travel, and that's particularly challenging if you're coming from a developing nation to be able to commit that time to it. But even when we're there, keep in mind our role in the current configuration is that we're there as observers. So we get very little opportunity to actually speak in the negotiations. I mean, you know, total speaking opportunities have been, you know, 2 or 3 occasions throughout all of the 5 negotiations in any kind of plenary setting. We've had lots of discussions with member states individually, one by one, but in terms of helping to pull things together around the science, there isn't a mechanism there to do it. And that, as a scientist, that frustrates me that we don't have such a process. I mean, there are aspirations to do it after the treaty is agreed. There are words in the draft text that would imply we would have some sort of subsidiary body. Even that is challenging to some countries because, of course, the best scientific evidence might not fit their individual purpose and advantage, and so there are concerns about that. But really, in my view, we needed it some time ago because there's no point agreeing on a treaty that doesn't align with the best available science. And then there's a worry to me that we could have a misalignment. But, you know, to come back to your question, there's a good number of countries that have got a really high ambition. We saw on the last day of negotiations in Busan, which was the last round in November, more than 100 countries come together. That they could see that the process might fall down with those of the lower ambition, that we might not reach an agreement in Busan. And they held a press conference on the last day, signing up to you know, a kind of agreement saying, look, we are those with a higher ambition. And, you know, basically they were saying, step up or get out of the treaty process if you don't want to align with this higher ambition.
Also, I just wanted to go back to something you mentioned about what ordinary folks can do and the lifestyle changes they can make. And can you talk a bit about that, and particularly things that say biodegradable on them? They sound a lot better, are they?
Well, let's start with the general things, and because the biodegradable is one aspect of it. So, I mean, if you can reduce your plastic footprint, then that makes sense. So, you know, I've got a refillable coffee cup in my bag that I've now been using for nearly a decade, the same one. You know, there's no point having 10 of them and all being in the cupboard. You've got to use the thing, right? And it's the same with a reusable, you know, jute bag, and a lot of us have been given them at different meetings and things, and I'm thinking, and I now just hand them back and say, no, I've got more of them than I need. What I need to do is to make sure that I'm using it and not getting another, you know, kind of single use, even if it claims to be a bag for life. A lot of these plastic bags are not, you know, they're not designed for really that long term. So there's things we can reuse and reduce the footprint there of them, things that we can do without. And then beyond that, I think it does get hard for the individual consumer if we've not got products that are properly designed for circularity. You know, I've got the benefit of a really sophisticated recycling truck that visits my curbside every week, and it's separated the stuff into different compartments. But I know that it's going to be a challenge for them to deal even with the things that they want to collect because of this complex mixture. But there are some things they're really clear that they don't want to collect, and even that can vary from one county to another. Yogurt pots are quite contentious because of the material they're made of. But all I can say to the general consumer is, if you're having to buy the plastic products, and I understand that there's no alternative in many cases, but if you can buy it in a wrapper or a container that, to the best of your understanding, is compatible with what your local authority says it can handle. That's a step in the right direction, because it's all going to be about economies of scale and volumes. Yes, we need to design better stuff, but if we can help the collection and sorting by giving them what they want and not giving them what they don't want, which is another part of the problem, is what we call the contamination of recycling streams, with all sorts of stuff being chucked in there that they weren't asking for. So I think those are the things you can do as a consumer at home. You're asking me about the biodegradables. Now, biodegradables have clearly got a place in this, but it's not a centre stage solution. I mean, if you think about the reasons that have made plastic so successful, there's 4 main reasons. And one of them is their durability, which is almost the opposite of the biodegradable. Then the fact that they're inexpensive, they're lightweight, and they're incredibly versatile. So, think of the lemonade bottle. We want it to last as long as it possibly can, to hold the lemonade while we want the lemonade to be intact and to retain the gas and it to be fizzy. How can that lemonade bottle magically know, if it's dropped as litter, that it's now time to self-destruct?
Yeah.
So you got 2 things that are slightly juxtaposed with each other. And there's an expert report, a review of nearly 20 scientists from around Europe that I was part of, about biodegradability of plastics, from a group called SAPIA, and it's free to download. But the conclusions that we reached in that report were that the advantages were coming in really quite specific niche circumstances. It isn't a solution to the challenge of marine litter, that the thing is going to magically disappear the minute we no longer want it, right? And so the advantages that we saw were where perhaps there was a use of plastic in the environment where it was going to be really difficult to recover it. And you could picture some examples in fisheries, and you could picture some examples perhaps in agriculture, where you've got a material that's used in the environment and it's going to be difficult to remove. And then designing it to be biodegradable might bring an advantage. It also leads to that particular advantage if we've got defined sort of time scale when the product needs to be durable. So if you picture perhaps a mulching film, we see these plastic films spread out on agricultural land to help crops to germinate earlier, perhaps. Now, and this is the challenge, because the biodegradability, let's not forget, it's not just a property of the material, it's what I'd call a systems property. It relies also, it's dependent on the receiving environment for you to achieve that degradation in a reasonable time frame. Then that's going to be driven by temperature and moisture and a whole range of things. So, that's a challenge with the biodegradability and the standards, that, just because you've got a standard that says X doesn't mean that it'll work from Scandinavia down to southern Italy. It's going to be context dependent. But theoretically, what I'm getting at is, if you could devise a product that was biodegradable, that would degrade at a sufficient rate and harmlessly, and this is all quite a challenge, and I don't know that we're necessarily there yet with some of those products, that you could use it on a field and plough it in at the end, and by the next season it would all have gone, because you know that you're not going to plant more till the next season. There's a potential advantage there to be realised. But the challenge is, as I've said, that you're not going to get the same rates of performance and the same rates of degradation, because you don't want it to degrade too quickly, but you also don't want it to degrade too slowly, and that's going to be driven by latitude. I was at a conference on biodegradables in agriculture just recently, and one of the speakers, and it horrified me a bit. I hadn't heard of it before, but he spoke of a country, and it almost doesn't matter which one. This isn't a finger pointing thing. A country that had been using these allegedly biodegradable plastics for a long time, and they now referred to one agricultural region in that country as having the white soils because of the amount of plastic that had accumulated in them. And I hadn't heard that before. I would love to get some more data on it. I mean, I don't imagine it was invented as a concept, but it shocked me a bit to think that there could be places now where the farmland is so contaminated with plastics that have not fully degraded. What they've done is disintegrated. So I'm not saying it isn't possible, but I'm saying we need to know what we're dealing with. It needs to be properly tested and labelled, and we need to be sure that it will work in the context where it's supposed to work. And for example, again, with those mulching films, we've tested some as part of a project recently, and what we found after 2 years was it's the circumstances. So in one environment, they seemed to disappear quite quickly. In other environments, they were very persistent. and that's about the context. And I could give you a similar example, let's say, of biodegradables, if we think of perhaps where it's contaminated with food waste, which is one of the other examples we came up with in the expert report. Particularly if it's something's wrapped meat, blood on it, it's going to be really challenging. So if it could be disposed of via a compostable pathway, that might make some sense. But here, let's be clear, we're not talking about home composting. Very few people have got the garden to have a home composter in it. We'd be talking about putting it perhaps with the scraps from the meat and fish dinner and it being compatible with that. But let's not forget that even in the UK, where we've got fairly advanced collection systems, I think it's only about a quarter of households that are actually connected to a waste collection that will take to a composting stream. And unless those compostable materials reach the right waste stream, and this is the point I'm trying to make about it's not just the material that's going to magically solve it all, it's got to get to the right place. And unless it gets to the right place, it's going to end up in landfill or incineration, and so it's not clear what advantage we've got from it. It has to reach the right place. And at the same time, there's also a concern from the recyclers that if we've got a product that's designed with, if you like, a self-destruct function, it's almost the last thing they want to see in the recycling stream with the new material they're making that they want to last.
Yeah.
So it's not straightforward. And to give you a really simple example of where it might work and it might not work, even for the same product. If we picture hot dogs and hamburgers sold at a big football stadium or a pop concert, you've got thousands of people there. You, as the director of that facility, the owner of it, have got complete control over what comes in. You've also got complete control of the waste stream that goes out and where it goes. So the idea that you could match the wrapping and its compostability with the waste stream that you're going to send it to, and that you then know that you're in control, that half the uneaten hamburgers and whatever it is and the wrappers could go the same way, you're in control of it. And you also know that those wrappers do not need to last for very long because the football game is going to be over in 3 hours. So you don't need a highly durable product to the extent that you might need one even on a supermarket shelf, right? So there's a real opportunity there. You've got scale from the big numbers, you've got time limited, you've got control of supply and control of the waste stream. But almost the same hamburger from a fast food takeaway on the high street, it's not going to work because it's going to end up in a bin, hopefully, maybe somewhere up and down the high street, mixed with all sorts of other waste. Yeah. So it's not going to bring the same advantage. So I think what we've got to do with these biodegradables is establish, and again, I would say that any criteria that we apply to conventional plastics about their essentiality, safety and sustainability, we need to apply to things that we might be considering as an alternative or a substitute to make sure that they're better, not just different. And that part of that is understanding the specifics of the circumstances, like the example I've given, with the football stadium hamburger versus the high street hamburger. So it's very much horses for courses, but there's definitely opportunities from biodegradable plastics where we've got the right receiving environment and where they've been properly designed and appropriately tested. And that testing has to match the conditions of the receiving environment, and there are very few of these products that have been tested to perform in the open environment. The tests don't necessarily match the conditions in the open environment, and we looked at a range of these products ourselves, and very few of them communicate that properly with the user. They're keen to say, I'm biodegradable, and there's a green picture of the planet or something on it, but it doesn't tell you how to dispose of it, and there's a risk. I work a lot with social scientists as well. There's a risk here that we could end up with going in the wrong direction if we get people to kind of have what the psychologists call techno-optimism, that they believe that there's this magic solution that they no longer have to play a part. It's biodegradable, I don't need to care what I do with it, I can drop it, I can put it in this bin, put it in that bin, it's all fine. And so there's a risk, and the same risk, I'd say, comes from cleanup devices, that if we all imagine there's some magic gizmo out there that's going to suck it all out the oceans, it might make us... it might make us not be so cautious ourselves, and we've tested one of those devices that's supposed to operate in ports and harbours, and regrettably what we found was it caught very small quantities of plastic, caught a lot of seaweed that we really want to leave in the ocean. It also caught quite a lot of fish, which by the time the device was emptied, even after a few days, were dead. So we need to be really clear that anything that's considered a solution, that we've tried and tested it in the right location.
Professor Richard Thompson, thanks for joining us.
No, thank you.